Alright, so this video is going to be about solving and graphing just a quadratic inequality. So much like you've solved back in Algebra 1 with just an inequality, and then you have to graph them on a number line. So basically here, the technique that I'm going to use is that you will have learned something about graphing. You'll have learned something about your x-intercepts for a quadratic. So essentially, to solve these, what you have to do is to factor them and solve them for their x-intercepts. Now, I'm just doing ones that are factorable. It doesn't matter what method you would do. You'd have to do something where you could solve for the x-intercepts to do these problems. So it's a pretty basic idea from there, but we're going to talk about it and what the graph looks like and how we get our answers and how they look like on the number line. So first things first, there's a couple of characteristics that I want to note about this quadratic that I have in red, and that is that the a is a positive 1. Because a is positive, okay, I need to know that this quadratic is going to go upwards. So this quadratic will pass through the x-axis, okay, right? And it will be greater than the x-axis on the two tails. So what you will have here is that you will have, okay, two intervals where the thing is going away from each other. So it will be greater, okay? It's not on a closed interval that goes from point to point. And you can see that here because of this point here, this part here, and this part here are when it's greater. They're two separate tails, okay? They're separated, they're not linked together. So that's kind of the idea here when it's greater than. For this one, that it's going to be that. Now we go over to the blue one, right? And for the blue one, the characteristic that we note is that it's negative, but it's greater than, right? So when it passes through, okay, in this case the x-axis here, okay, what we need to note is that I want to know when this quadratic is above, okay, the x-axis. So when it's above the x-axis, what you can see here is that it ends up being on this closed interval from only this point here to this point here, and everything then in between. So that's one of the characteristics to kind of note here to kind of help you when you're graphing it. I would just prefer to be able to look at the graph and say, hey, what's going on? And to notice and see what the things are happening here. So an example of this, just to move forward here with you a little bit, okay, is this. So here's the problem, okay? And the problem says x squared plus 5x plus 6. So we're going to go ahead and factor that, and that factors into x plus 3 times x plus 2, all right? And we're just going to solve this just for the x-intercept. So instead of being an inequality, okay, we're just going to go equal to. And we're going to use the inequality in the sense of just analyzing it and understanding it. So anyhow, the x-intercepts here are when x equals negative 3, okay, or when x equals negative 2, all right? So at this point, okay, this is what I want to talk about with this quadratic again. At this point here, I have negative 3, and at this point I have negative 2. Now, generally speaking, all right, if this were a graph on a coordinate plane, all right, you'd have this graph would be going up like this and up like this. Well, when you're on a number line, you're only concerned about the domain. You don't care about the range. You don't care about how it goes up or down. So what you have here is that this will go like this, okay? So it's just going to be greater than, okay, the negative 3 or greater than the negative 2. Now, it's an equal to problem, so I'm going to fill in a solid circle here. And what I have here is that you notice that the points are going away from each other. So greater than, you're just observing and thinking about on a graph, when are these two things greater than, okay? And in this case, you have basically an inequality that looks like the good old OR inequality from back in the day. All right, so now we go on to the next one. So now it's negative. So now we go through and factor this one. So now when you ever factor this, remember you're going to take out the negative 1. So the negative 1 comes out, and I'm left with x squared minus 5x plus 6. And I'm going to set that equal to 0 and just solve it like normal. So now we're going to have to come back and answer this question at the end, so just be careful about that. All right. So here we go. This factors into negative 1 times x minus 3 times x minus 2 is equivalent to 0. And what I get here is that x equals 3 or x equals 2. Now, because it was negative, okay, if we think about this on a graph, all right, if it was negative, it opens downward. And because it opens downward, it's basically going to go from one point on the axis to another point on the axis, and then everything in between that now, okay, would make it be greater. And the reason that it's going to be on a closed interval is because it's going to go up and then it's going to come back down. All right, so in this case, if it's greater than a negative, okay, what I got here is I've got this number line coming along, and I go from 2 to 3. They're both going to be closed circles. So let me do some white here. Okay, because they're equal to, they'll both be closed circles. And then if you notice here, again, all right, because it's only one variable, we only care about the domain of x. So we notice that it goes from 2 to 3. All right, from 2 to 3, okay, I will be above the x-axis for this quadratic. All right, so I hope this helps or you're understanding what it is that I'm talking about. You may or may not. If you don't like this, there's another method that people put out there and it has testing points. I'm just not a fan of testing points. This is really kind of like a basic idea, but you have to know how to graph a quadratic. So if you don't know how to graph a quadratic, this video really isn't for you. On to the next one. So again, we have another quadratic. Again, I take a look at the red one, and what I should know is that this quadratic opens upward. So when it passes through, so the 0 that I pass through, okay, if it's below the line, okay, that means it's less than. If it's above, it means it's greater than. That's that simple. So in this case, I'm looking for less than 0, so I'm looking for this interval here. Well, by knowing that, I know I have a closed interval. Okay, I have a closed interval from here to here, so I know that this one will be connected points when I go ahead and graph it for my solution. So here we go. Let's go ahead and do it. So this one factors into x, okay, minus 9, x plus 2, and we just set it equal to 0, okay, because at this point we know we're just going to connect our points when we get our answers. So we have x equals 9 for the first x-intercept, and x equals negative 2 is the next intercept. So when I go ahead and graph this on a number line, okay, at negative 2, I'm going to have an open circle simply because it's not equal to here, right? Right, not equal to. All right, so that's where it's an open circle. And again, for 9, it's an open circle. So I go to 9, put an open circle. Now again, what I was talking about here, okay, I want it to be less than 0. And because it opened upwards, okay, it went down below, but then it started heading back to being a greater again. So it stayed below only between the 2 points. Okay, so therefore I go ahead and I connect them like such. And there you go, I have my solution. All right, so again, taking a look at another one here. All right, so it says negative x plus 9. It wants to know when this one is going to be less than 0. So again, just take a quick little graph here and just take a look at it. So it has this negative x. Well, if a is negative, then I've got a quadratic that opens downward. So if I were to draw this on a graph, what you should know is that this is what the quadratic would look like on the graph. It's opening downward. Okay, when it passes through the x-axis, okay, I want to know when it's less than. Well, it's less than from this point down and from this point down. So what I'm going to have, all right, when I graph this on just a number line, is I have a 1 point going this way and another point going that way, because again, we're only talking about domain. So these two have arrows that are just simply pointing opposite of each other. So let's go ahead and solve for this one. So here we go. All right, so for this particular case, again, if it's a negative, we factor it out. So negative 1, factor it out, and I get left with x squared minus 12x plus 11. That is going to now be equal to 0. Again, we just solve it, set it equal to 0, and just apply this property to find them. And then we're just going to answer this question at the end. So here we go. So you get negative 1 times, so this is x minus 11 times x minus 1 is equal to 0. So I get x equals 11, or I get x equals 1. So again, what we talked about here, all right, Again, what we talked about here was when it opens downward again. So if I just draw this down here again, just to have this, all right, if it opens downward, we need to know I want it to be less than. So I want to know when's this going to be less than. So here's the one point that I found, here's the other point that I found, and then it will be less than. So now again, we're only caring about the domain, so my points are going to go opposite of each other. Okay, so here we go, draw it in there. So at this point here, this is 1. This point here is 11. I put an open circle because it's not equal to. And I notice that it will be to the left of that. I go to 11 and go to the right because down below the picture is just simply showing that they're going opposite of one another. So to show this here, I go this way and this way. But on a number line, again, I only care about the domain, so I would only map it from left to right. So there you go. So I hope that helps with whatever you're doing. If you like this video, give it a, let me know if you like it. If you don't like it, that's fine. But again, this video is based on, do you know how to graph? If you don't know how to graph, you don't understand the visual of a quadratic, I would highly suggest that you take some time to look at my video on transformations of quadratics so that you can get a better understanding of what you're doing here. But I prefer not to do that whole testing a point thing. I think that just takes way too long. When you can just look at this and go, okay, less than, it doesn't mean that it's always in between, and greater doesn't always mean that. So you just look at the graph and you kind of visualize it, what kind of graph it would have, and you go from there and see what it has. So I hope that helps, but this is how I prefer to solve and graph quadratic inequalities.